Check it. I figured out how to change the ratio. Boom! Now it's most of the screen that, like, is my paper. All right, so down here, this is what we were talking about and kind of, like, mildly arguing. They were wanting to divide, I want to multiply, and we all know that's essentially the same thing, so our argument is silly, but hey, it's middle school, so that's fine. Up here, we want to remind ourselves how to deal with a measurement that has already been calculated when they ask us for the complete other one. Now, what do I mean by that? Like, we talked about circumference and area, and how to calculate either circumference, which we normally use diameter, right, like I have here. There's another circumference formula, we just don't like it as much, right? So if you want, sure, you can go ahead and write down the other formula. If I replace D with 2 times R, we can also do that. But we're not probably going to use that, because when they give us area, we got to work backwards to find the radius, and then work forwards to find the circumference, or vice versa. If they give us circumference and ask for area, we're just going to figure out what we can utilizing circumference, right? So let's go ahead, and since they tell us circumference is 50.24, let's write down, we'll use green since yesterday was St. Patrick's Day. I would go far off to the left because we're going to split our space here a little bit. Let's write down our circumference formula of C equals pi times D. Crust equals pi dough if you need a little memory trick there. So then, I actually disagree with myself. Right, I taught you guys crust equals pi dough. Every time we talk about the formula, you pretty much see C equals pi times D. But I actually want us to start writing it D times pi. Now, in this case, it won't really make a difference, but later in the paper, hopefully you'll see why I'm talking about that. So, if, like, either way that you write it, you actually don't really need to write this one here. It really comes up more later. I should have left that till later. If I replace pi with 3.14, man, I'm goofing this up because you guys came in immediately talking to me about math and you got me all confused. Well, more so excited about you guys being excited. I'm going to bump over here and, like, do this again. C equals pi times D. I'm going to replace C with what they told me. I'm going to replace pi, again, with, like, what they told me. Right? Pi is 3.14, or what we know, I guess we could argue. So this is why, in this case, we can go ahead and keep writing pi times D. But if we have something times our diameter that we want to solve for, how do we get diameter by itself here? Divide, yeah. So, guys, if you don't have a calculator, I would grab one. All of those got sprayed off last night because I had them sitting out, and then I put them back in the rack so they are clean. If you borrow one of mine, please wipe it off afterwards. But guys, I don't know how to divide by 3.14. That's tough. Use a calculator. This is tough math. Don't, like, try to be a hero and do it in your head. Like, how you pull a hammy. Sorry, that's a joke about, like, when you try to, like, lift too much weight, you might pull a hamstring. I think this is actually 16. And if the diameter is 16, what else do we know? Nah, well, yeah, but I just always want to think about this. Even if it's not important here, I always want to remind us, if we know the diameter, we know the radius. Now here, we don't really need it to find, wait, yeah, we do. We're looking for area. So we were given the circumference. We were asked to find the area. We got the diameter, which also tells us the radius. How do we find the area? Pi times radius squared. Guys, here is where I'm going to start writing radius squared first. And flip that order around. Because it's easier to put the number first. So 8 squared times pi. Because we can leave the pi as pi. And something I didn't realize I should remind you of, you can type pi in con, and it knows you're talking about pi. If you type pi, like pi, because that's how we spell the Greek letter pi, There's no E, unlike the delicious apple cherry, whatever you want to put in your pie. Pi will, like, it doesn't convert. Sometimes it actually does convert to the symbol, but even if it doesn't, it knows that you're talking about pi. So the answer that we could type in con, 64, you could literally type in pi. Or if we were writing this out, 64, and we can just put the symbol, and if you figure out how to type the symbol in con, then you can just type the symbol. Gotta have a label. Units squared. Because area is always squared. We will come back to this other question if we have time, or if you get bored during the lesson, feel free to tackle that one on your own. Isis? Sorry, what was that? Or do we... This is the answer. So, we can do times 3.14, but we don't have to. So, if you guys remember yesterday, we talked about in terms of pi. I got extra copies of these too, in case anyone needs copies, like the notes from yesterday, which of course was Tuesday. But we talked about using in terms of pi, and that we're allowed to just leave our answer in terms of pi. So this is actually the same problem that we solved over there with the radius of 8. Yeah, that's fun. I didn't notice until right now too. But if we go ahead and multiply by 3.14, which we can, we get 200.96 units squared. The funny thing is there's only so many one-digit numbers, right? Approximately 9 of them. So if we're trying to be nice and just use a one-digit number, the problems are going to end up circling back again. So that's what just happened. Like, that was a nice problem. This one is not bad. I don't know if I would call this super nice, but it works out to whole numbers. All right, so now to the meat of our lesson today. You know what I mean? Not the salad, not the vegetables, the meat, the important stuff. Sorry if you're a vegetarian. I lived that life with my wife for a hot minute. Don't say that. You'll email me when you're 20 and you'll be like, Mr. Hudson. And by then I hope you just call me Micah, but you'll be like, I am now a vegetarian. And I will be like, haha. And then like 3 years later you'll be like, yeah, I came back to eating meat.
I was a vegetarian and then COVID happened and there was lots of options.
Yeah. So arc length means a partial circumference, a portion of a circumference. Down here, the first problem that we're going to do, but I did out for you, really. You guys don't have any work to do in this problem. I did it all for you. You're welcome. But I do want you to write, where it says find the radius or diameter, whatever we don't have, if you're given the diameter, think about what is my radius. If you're given the radius, think about what is my diameter. Depending on what you're solving, you'll either need radius or you'll need diameter, right? So since we're looking for a partial circumference here, step 2, which really I call step 1, I really think this is step 0. Sorry, this is what happens when I copy paste things. I got to deal with they said step 1. But this is really step 1 to me. We find the entire circumference, right? So to get down to the portion, we treat it like it's the whole circle. I'm going to write out my formula, because notice this is copied from Con, and I did this on purpose. They're using the alternative formula, right? They're using 2 times pi times r, because the 2 times r is the same thing as diameter. That's fine, but I don't like it. Like, it's fine. It works fine. I just like my crust equals pi dough formula better. So I'm just going to use the diameter that they give us of 8 and say pi times 8. Oh, here's what Mr. Hudson was talking about like 10 minutes ago when he got confused and said the wrong thing up here. This is when putting the number first would be a lot nicer, and I could just say it's 8 pi. Notice that even if I use the other formula, the not-so-good formula, it gets the same answer. I know, I'm a very biased person. I'm sorry. Actually, I'm not sorry. This is a better formula. It's cleaner. There's less to do. I'm not going to apologize for saying you should use this one over that one. And then, ladies, we multiply. Okay, or we could divide. They convinced me with their eyes. They're like, Hudson, you're full of it. So either we multiply by a half or we divide by 2. It doesn't matter. I just like to argue with people. Dang it! You're going on my to-do list. I literally have a to-do list, and you're going on it because I need to buy Kit Kats. Well, I don't know. That's going to be up to her. The pie. So this turns into 4 pi, or if we want to use numbers instead of the pi symbol and we multiply by 3.14, 12.56, I believe. And that would just be units, right? So we could just say U for units. Please make sure we're writing this stuff down. So I'm going to do one more with you and then release you to work on your own for a couple minutes. I would split up your whole bottom section. I would split here and here under each one. So I would divide this into 6 pieces. I'll show you why, because I have a done copy of notes to show you. This is how we're going to set up these bottom problems. We're going to first, sorry, my back kind of hurts, so I'm going to stretch for a second. We're going to first find the entire circumference if the circle was whole. Then we're going to specifically look at the arc and say, well, the arc is 3/4. This is when I think multiplication is better. This arc is 3/4 of the circumference. So I do 3/4 of, tells me to multiply 10 pi, and that gives me 7.5 pi.
But it's easier because you could just divide 0.25.
Divide 0.25? You mean subtract 1/4 of it away? I disagree. I think you're trying to defend yourself, but you're going to do more steps. I bet you mine is less steps. I bet you a bag of Kit Kats that mine is less steps. So try that on the next circles. Right, if they give you the radius, we're going to need to first find the diameter. And then we're going to do how much of the circle do we have, and multiply if you want to take the easy route, divide and subtract, and I don't even know what the heck they're doing over there, but you can follow Madeline and Miriam if you want. I think it's dangerous, but it's a dangerous pathway. Drew finally gave in and got a calculator. Drew got a haircut too. Dang, dude. I gotta go get one. My hair's getting out of control. Guys, it's my sideburns, so they make me look like a wolf. This is too long. You can't tell because my mask covers it up, but these sideburns are too long. You're lying. Tell me what you did then.
Okay, first I just found the circumference.
Are we doing the middle one now?
Yeah.
Okay, so how'd you find the circumference?
8 times 2 is 16 times 5.
Okay. Oh, so you go ahead and find the decimal value here? I mean, then maybe your way is not terrible.
0.75.
What? Divide? Why are you dividing by 3/4?
Because that's how much is gone.
But we would need to subtract 3/4 of the... So is your answer 12.56? Because I'm worried that it's not. Guys, please ask questions if you're confused, but I think they're just digging in their heels and trying to like make division work. I suggest we just multiply. So when we do this, what could work, I'll give you some credit here, guys. What could work in this one is we just divide by 4 because this is a fourth of the circle. But in a problem like this, it's 3/4. So if we divide it by 4, we would then need to multiply by 3 still. So that's where it's an extra step. Or if we multiply, it's 1/4, right? 1/4 of 16 pi. Oh, wait, what's 1/4 of 16? Oh, it's 4. So we get 4 pi. Or 12.56. Questions? Yeah. So, yeah, sorry, that one's in a sheet protector. This is a quarter of the entire circle, right? So if we envision the whole circle, we say, oh, and because this is a right angle, that tells us that it's 1/4 of what the whole circle would be, right? Because then there would be a part going this way, part going this way, like radius is going each direction. This is 1/4. So that's why we use the fraction 1/4. Do we have the last one done, or do we need more time? And division works. Division works on this one. Yeah. So we're going to end up doing half of 12 pi, which is 6 pi, or 18.84 if we multiply by 3.14. Guys, please ask me if you have questions, like right now. You don't know how to what?
I don't know how to ask. I don't really understand it, but I don't know how to ask.
So, I thank you. You're at least asking, like, hey, can you explain it again? Which I dig it. Oh, I just was writing something wrong. I wrote the 2 first, or so I don't even know. So, I'm going to go through purple and brown. So, we act like the circle is whole, and we find out what the circumference of the entire circle would be. So if we had the whole thing, the entire distance around that circle would be 16 pi, or as a decimal, that's actually like 50.24. So let's say if this is feet, right? So it's about 50 feet around the circle. Let's just call it feet. But we don't have to go all the way around the circle. We just have to go from here to here. So that much of the circle is 1/4 of the entire circumference, right, of the entire distance around. So it's like if you start riding your bike and stop before your tire even goes around the whole time, right? Or if you like your car just backs up just a little bit. So 1/4 of what we found to be what the circumference would have been. So I could also, if I want to use the decimal numbers, do 1/4 of the 50.24, 12.56. So this distance would be 12.56 feet, or whatever we're talking about. Same thing over here, except these 6's that I wrote don't matter. They're true, because if this is the diameter of 12, right, it tells us the distance all the way across is 12. So we get to work with the 12. Unlike over here, where we had to say, oh, well, if the radius is 8, the diameter would have been 16, because if we had the whole circle, the distance across the entire thing would have been 16. So is all of this making sense still? Yeah? 23.55? I think. All right, so in this last one, diameter was 12. So our circumference formula tells us we just need to do diameter times pi. Guys, this is actually one time when I'm going to tell you, like, don't do more work. Well, actually, I pretty much always say this. Don't do more work than you need to do. Right? That's just silly. So we can leave it at 12 pi, and that 12 is easier to work with. Right? The pi is still there. But when we come over here and we say, what is half of it? Excuse me. Well, half of 12 is 6, and the pi just comes along. Because when we compare 12 pi to 6 pi, this is half. And if we multiply by 3.14, we get 18.84. But we don't need to. You really don't need to get that answer. You can leave your answer as 6 pi, and you could type it into Khan as 6 pi. Other questions from the front? To the back, to the back, to the back, to the... No? Okay. On the back, similar to on the front, I got a problem completely done for you guys. I like to be honest. There is another area formula. Just like there's another circumference formula that I don't really like. Don't worry, I like all people, but there are math formulas that I just don't like. So, I like this formula, pi r squared, that we've talked about. If you want another way to do it, guys, I don't like this, but this is true. Because radius is the diameter divided by 2. So if we replace the radius with diameter divided by 2, this is still true. So if you're given the diameter, I mean, sure, you could use this formula. So guys, technically, you could find circumference or area using radius or diameter. Like either of them can be used. All right, because they directly relate to each other. So look through this work as we talk about it. They show us the radius is 6. So when we go to our formula, pi r squared, we will plug in our radius of 6. Guys, this is where people keep messing up. 6 squared is not 12. 6 squared is not times 2. This 2 is the most tricky thing there is. Because that means I have 2 6's multiplying. And what is 6 times 6? 36. The biggest mistakes I keep seeing is people are walking in my room saying, why did I get this wrong? And I say, what is 6 squared? And they're like, 12. I'm like, no. And they're like, oh, gosh. Like, it's so tricky. That's the trap door here. I'm trying to warn you so you don't step in it. Hop over it, walk around it, do a little dance to the side. Avoid it. When we square, it's not doubling. Except for one number. There is one number that when squared just doubles. Not 4. Not 1. 2. Because 2 squared is 2 times 2. Right? How tricky is that? 2 squared is the same thing as... So don't think about it. Let's think about numbers like 6 that actually make sense when we square them. Then we multiply, or I guess we could divide. Okay. Do you know Alina in the 8th grade? Yeah. So she last year would love to just fight with me. And of course, because it was pre-COVID, in my classroom over in Phoenix, I had a coffee table and just pillows that you could sit on the floor. So she would lay on the floor on her iPad taking notes and just argue with me. Kind of like you guys were doing at the beginning of class. And it was really fun. It just became a thing that we would argue about math.
Yeah. She's the one I owe Kit Kat.
So I owe you Kit Kats and you owe her Kit Kat?
I owe her a Kit Kat because she's the one who recommended it.
Was it her?
Yeah.
Dang it.
She told me on the phone.
Darn Alina. Alright, so when we do that half, we get 18 pi, or if we do the multiplication, 56.52. Any preguntas? Again, I'm going to show you one more and then have you do the others on your own. What? Yeah, except for me. I'm just special. You guys are smart kids too. You guys hear that? Madeline just called them the smart kids. I think we're the smart kids. All right, down here, by the way, vocab, and if you play video games, this might start to make a whole lot of sense. A sector is a portion of an area, right? So a sector, now specifically in circles, a portion of a circle is going to be like a semicircle, a quarter circle, something like that. But if you've ever or heard of places like Sector 7, it's just a part of a place. Like, it's normally like, oh, that sector is within the base or something like that. So the sector area is how much area is taken up by half the circle, or a quarter of the circle, or 3/4 of the circle. So same thing we did with circumference, and that's why I'm just about to flip my timer and give you guys 5 minutes to try these on your own. And if you want, you could write like full over here if you feel like it. Like, we act like it's a full circle. Dang it, this is that tricky one we talked about. Where 2 squared is the same thing as 2 times 2. Be careful, don't fall in that trap on the next ones, right? The next ones do not do that. So, if the circle was full, the area would be 4 pi. But we don't have the full circle. We have half of it, so we multiply, or I guess we could divide. Since you would just divide by 2 here, I guess it would be less to type into the calculator. So you guys could have won more Kit Kats there. Because you could have proved me that division on this one is easier.
We did.
No, because on the one that you were arguing, it wouldn't have been, because 3/4. No, but we were on the 3/4 one. But she also didn't take the bet. Remember, she said no. So even if I lost the bet, it doesn't matter because she didn't take the bet. Like how Jocelyn's just looking like... That's what even the rotation problems. Do you know where the copier is? Because I'm going to send the next set of notes because I think we're going to get to them. Do you know where the copier is? No, it's right past Kabila's room in the clinic. Because we're going to get to the next set, probably. So, if you haven't done these yet, you should be doing the next 2 problems. Right? If you haven't done them yet. If you have done those, move on down to the rotation problems. And actually, I'm just going to give you 5, and I'm going to run and go grab those copies, because you have 5 minutes to work. What in the world? Why did Google sign me out of everything? What do you mean, how to write the things down? I still don't know what you mean, what I did on the other ones. Like this? What, you want to instead just do that? And write the division? Or what? Because that's the same, 4 pi over 2. Like in con or on your paper? You can either just write 2 pi, or do you mean you don't know how to make pi? I would. I mean, you want my honest answer or you want the teacher answer? My honest answer is if you feel confident with this stuff, you don't need to write down any of it. But my teacher answer is anytime we write things down, it's good for us. So my honest answer, do what you feel like you need practice on. If you feel confident on these, you're okay. Move on to the rotation problems. Oh yeah, shaded areas too. I forgot about that. This is fun, guys. It's about to get sweet. Get excited, y'all. Do an area of shaded areas. I have not heard a 12-year-old say over the moon in I don't know if ever. 13, sorry. I forget we're in spring. Most of you are getting 13 now.
I was in October.
I'm over the moon. I haven't even heard an adult say that in a while. That's fun. I'll be right back. Shushing that I assume is coming from here. You guys know that I'm recording, right? So I can just go back and see what happened. Well, Madeline and Miriam get to teach the next two problems. So how do you do for that?
Since when?
Because you guys said you know what you're doing.
Okay, I got it right. I figured it out. I can do this.
Oh, did you guys move my paper?
No.
You sure?
You moved it. Yeah.
No, it's fine. So, yeah, if we calculate the oh, yeah, we don't need the diameter anymore, right? We don't need the diameter, so the radius is all we care about. 8 squared, 64, not 16. Double check. That moment is why I teach. Like when I realize like my plumbing is turned off and that's why there's no water coming out of the sink. Or like those moments of like, oh, I got it. Yes. Yep. Yeah, that's like whatever we get to today and then tomorrow. Because tomorrow's Friday. Woo-hoo. And the last one, 4 squared is 16. Did I? All right, so we're actually going to bump over to tomorrow's notes real quick to give us like a reminder before we do the next 3 problems on the bottom of this notes. One rotation is a circumference. Because guys, think about it. Yes, we are going back, so don't put them away. If this is my wheel and I'm on the ground, where'd my meter stick go? Is that what Miss Allie does?
That's what our old EP teacher would do. She'd slap a roller on the desk if someone fell asleep.
I just normally pick up the desk and drop you. But if you're asleep, I just pick up the front of the desk and just gravity. I didn't do anything. Gravity did it. So if I travel one wheel rotation, this is going to start leaking probably. Like my spout goes all the way down to the bottom and then all the way back up to the top.
Maybe I would move it.
That distance, we should be okay. I think it leaked everything it had to leak. That distance is the same as the distance around the outside of my wheel, which is the circumference, right? So when we talk about a rotation or a revolution, not like an uprising, like let's use lockers, like a revolution of a wheel, that's a rotation and that's a circumference. So all we need to do to figure out one rotation is if we know the diameter, just multiply it by pi. Sorry, I can't always find like the fancy looking pi's. This is pi. And that gives you the circumference. And that is actually a unit rate, right? Because that's per one rotation. So the circumference is actually your unit rate of distance per rotation. So when we look at problems like our bicycle tire problem, yeah, revolution also means rotation. Revolution also can mean like an uprising of people, is the joke that I was... Try it. I don't know. I'm not going to do anything. Actually, probably worst case scenario, they just keep taking your stuff out of the lockers and putting it in the office and make your parents come pick it up. And your parents will yell at you and then you'll stop doing it. No, I'm telling you, that's what would happen. Oh, 100% they would take your stuff out and put it in the office. I don't know that they would actually check all the lockers every night, but yeah, they'd be upset at you. It's COVID. They'd have to clean everything. Oh, they would still take your stuff. Like, they would watch you do it and then be like, nope. I'm telling you, Mr. Shoop's a great guy, but he likes messing with people too, and he would take that on as like his like ninja duty to make sure that there is no like, yeah. Well, I said duty. All right, so one rotation is the circumference. So if we find the circumference is 62 pi, well, guys, again, you could do 62 times 3.14 and go ahead. That's bigger than I wanted it to be because there was a number there. That would be 149.68. But how many rotations? Oh, yeah, they use the word revolution here. 10 of them, we then would need to multiply by 10. I lost my work paper. I had a piece of graph paper with my work on it. Nope, I lost. Oh, there it is. Aha! I threw it away for some reason. Well, put it in the recycling. So then, 10 rotations, when we multiply by 10, it bumps the decimal over, and we get 1946.8. Make sure you're not using your pi button. Make sure you're using 3.14. Same deal for Stanley. If you like my beautiful little picture here, that was me trying to show that like a point on a wheel goes up and down and up and down and up and down like the whole time that it's moving. Or what?
Yeah.
Oh yeah, to the nearest centimeter. So sorry, the 1947. What do you mean wait what? Who is wait whatting? Because I do want to take whatever your question is. So check this work. One distance around the circle. One rotation. I tried to draw some cute little pictures to go with. That's an arrow. I know it doesn't look like it. Is the circumference. So we calculated the circumference. And then, instead of having a portion of it, like we were doing on the front of the notes, now we have multiple of them. Because the wheel spun 10 times. So if the wheel spun 10 times to go from one rotation to 10 rotations, we just multiply by 10, right? How do I turn 1 into 10? We multiply by 10. And then it tells us to round to the nearest centimeter, so we get 1947. Now the next one, you probably got to come with me like along as I solve it if you haven't done this yet. They tell us Stan has driven 3,300 meters, right? That's not miles, that's meters, to the grocery store. The tires on his truck are 2.2 meters in circumference. So guys, that tells us one rotation. We abbreviate rotation with ROT. So we know one rotation is 2.2 meters. Every time it spins, 2.2 meters on the road, right? So the distance on the road for every spin is 2.2 meters. The whole distance he traveled was 3,300. So there are two different ways to do this. We can do the work that I have written down here, or, guys, you could just take the total distance that he traveled and divide it by each wheel rotation, right? Because if he traveled a total of 3,300 and each wheel rotation is 2.2 and both of these numbers were measured in meters, right? The meters actually cancel out and our answer is number of rotations, which is 1,500. We could also set up a proportional relationship and say, oh yeah, well, it's going to be proportional because if it's a for every situation, that's proportional. So if it's 2.2 meters per rotation, how do I get to 3,300 meters? Well, if we don't know how to multiply forwards, remember when we did our proportion solving, we can divide it backwards. So I do 3,300 divided by 2.2. Oh, wait, that's what I just did up here. Either way, essentially, I'm going to be doing 3,300 divided by 2.2. And then Benjamin, and then I'm actually just going to give you guys the rest of the class to work on the problems that are on tomorrow's notes. So tomorrow we can just like solve problems and do those. But Benjamin's situation over here, Benjamin, I'm just saying Benjamin, like, never mind. Sorry, I had a friend named Ben, and that's often what we called him. Circumference, right? That's one rotation. I always make a little note. If they tell us circumference, that is one rotation. Well, if one rotation is 2.8 meters, I'm going to zoom down into this one. If one rotation is 2.8 meters, how do I get to 1.5 rotations? We'll do 1.5 of it. That's 4.2. So that tells us for each second, because they tell us 1.5 rotations per second. So 1.5 of my 2.8, 4.2 meters every second. How far in 100 seconds? Well, if this is 1 second, multiply by 100. And we get 420 meters per 100 seconds. Questions, comments, concerns? Queries, quandaries? I'm out of words. Preguntas? So grab tomorrow's notes, pick whatever problem you want that looks interesting to you, and just try another one. Guys, these are also exactly what you're going to see on Khan Academy, like half of the potential problems. So get with a partner if you want, like whoever you're close enough to talk to, talk about how do you solve these problems. I'm going to come around with white, so we got a couple minutes. And anyways, you guys are finishing Angry, whatever the play is, 12 Angry Men. So if Miss Allie isn't ready for you guys, I'm just going to keep you for because yesterday she was running a little bit long, so I'm going to go check if she's ready. Just go ahead and try to solve these problems while we're sitting here. I will tell you, if you flip to the back of tomorrow's notes, I don't think a lot of you have tried that homework yet, but when we have these shaded areas, the back bottom, if you want to look at tomorrow's notes, that's always going to be a subtraction. We're always going to find the area of the bigger shape, the area of the smaller shape, and do the subtraction to find what is left. So like in this first problem here, we would figure out the area of the circle using that this indicates the radius. And on Khan, it's all color-coded, so you can really tell. That 4 indicates the radius. So you'd figure out the area of the entire circle, then you figure out the area of the rectangle, and we subtract. That's it. There's nothing super tricky here, but you have to do the work, right? There's no like quick and easy, like plug all the numbers, like, no, we just got to write it down, right? We got to just do the work. I have a feeling that was the end of the play, so I'm thinking they may be ready. Or maybe not. Maybe they're upset. they're done. They actually finished. So let's pack it up, head on out. Pack it up, pack it in, let me begin. I came to rhyme battle me, that's a sin. There's a swear word in the next line that I can't say. Messes up my flow. There you can't go. You'd like to make a bet with me? Okay, bet. You can't make it super unfair because then I'm just not going to agree to it. So if one person, but I'm already holding my breath that it's not going to be fair. If one person actually, I don't get that question as much as you might think I do.
Well, this I feel like is going. I was thinking it in my head. So.
Are you serious? When will we ever need this? Anytime you're dealing with circles. So what I thought you came into my room and said, was I helped my neighbor find the circumference, and I assumed you were going to say something like a flower bed or whatever. But seriously, back before I made my patio, and my wife and I wanted to do a stone fire pit, the stone fire pit that we were going to make, right, what I needed to calculate was how big do I want it to be, right, how wide, based off how I want people to be able to sit around it. Then what is the circumference around the outside? I then had to divide that by each brick length to figure out how many bricks I needed to buy, right, like things like that. This is super practical. But so like if you were doing like a flower bed, like a round flower bed and trying to edge it with rocks or whatever, or if you were trying to find the area of the flower bed to put mulch on it. Oh, angular momentum. You're like 13. You have no idea what you're going to do with your life.
I want to be a therapist.
Well, like rotational angles of muscles. Like seriously, they will tell you how many degrees and things like that. Like, oh, like okay. I thought you meant physical therapist. Sorry, I assumed I wanted to spin it for math. Spin it. Yeah.